Yay. All right. Here. Problem number 1, page 103. So,
Hey, thanks.
all right. So this is our parent function, and really the only thing we need to really focus on is the vertex. I mean, it's definitely a good point to focus on. We can see rotations and stuff. So in red, we have f at x minus 5 plus 2. So this goes right 5 up 2. I'll wait. Is that okay?
Yes.
So from my original parent function that's up there, I'm going to go right 5. So 1, 2, 3, 4, 5. And up 2. It still opens downward. So that's what that one did. Okay, so we're just showing the rotation, or the transformation. That was problem number 1 on 107.
Why don't we use vertex form and turn it into 5 times 2?
You're absolutely right. If this was a parabola just given to you, but this is saying, hey, we have this original parabola. What happens if we plug x minus 5 in for the x value of whatever that parabola would be? Because we don't even have the equation at this point. And what other shifts? So that's just the shifts that are taking place. Letter B, we have negative f at x plus 3. Okay, so that negative flips it.
Upside down.
Flips over.
Over.
So it's going to make it go up, yeah?
Is it only, so like in A, it's negative 5, so right 5 up 2. And it's the opposite since it's negative, so you go right. And is that only on when you're going on the x-axis? Okay.
When it's grouped, you always go opposite of what you would think you would go. I think they made that to goof up all our brains.
So if it was
plus 5, you'd move left.
Yeah, and then if it was negative 2, you put down 2.
Yes. All right, so this flips the whole thing over. So this whole thing's going to open up. And because that negative out front, that changes all y values. Okay? So I'm going to do this twofold. Yes, sir?
What scenario would you use this for now? Like, what type of, what would you use for?
Well, here's the great thing. Oh, absolutely. But what's cool is these rules here apply to every shift that will ever take place in math, all the way through calculus 20. So you're learning it here, but then when you see it next year, when you're working more with like logarithmic function, or 2 years logarithmic functions, or more exponential functions, things like that, you'll see it. So
Like rockets.
like rockets. I'll take rockets. I like rockets. All right, so this flips over, so it opens opposite, and it changes all the y values. So if I look at this, my new y value is going to be down 1, 2, 3, 4. So this is now going to come down here, and I'm going to make this a round point for right now. Okay? I'm going to make it a round point because I'm not done with that point. And I'm going to go up 3. Awesome. So this took place because of this right here. Does that make sense?
Yes.
Now I have this plus 3, so this point is going to go up 1, 2, 3. And it opens up. Okay? So you have to remember that it flips over, but then you go up 3 as well once you do the flip. Don't try, there's times where if you go in the wrong order, it's really going to change things in your mind to really goofy stuff, which is kind of fun, but I just suggest stick with it. All right, so f at negative x.
This one flips over the y.
Yeah, it flips over the y. Sometimes it's hard to see on a parabola what's really going. So this changes all x values. Okay, so if, let's say I gave you one of these problems and you had 10 ordered pairs, so 3, 6, 10, 8, whatever. All of the x values will change to the opposite value. So if they're positive, they change to negative. If they're negative, they change to positive. And then this will move it down 4. Okay? So I'm going to change this value here. It's going to come over here now to 2, 5. So I made an open circle. And then the whole thing's going to move down 4. So 1, 2, 3, 4. Kind of off, so I'll make my dot bigger. And that's what that parabola does. Okay? Then problem number 2. So that's a exponential decay. How do you know it's decay? Because as you go to the right, our graph comes to the asymptote. Okay? What you have to remember with these is if you add or subtract something outside, so something that's not grouped, it moves your asymptote. So right now my asymptote's right here. Okay? So, for this one, I have f at x plus 2 minus 1. So this goes left 2, down 1. Is that right? So I'm going to take this point right here, and I'm going to go left 2 and down 1. So it comes right here. But if something outside's taking place, so if either I'm adding or subtracting a number, that's also going to move my asymptote. So what's my asymptote going to do on this problem? Go down. Good. It's going to go down 1. So now, here's my asymptote here. Okay, that moved down. So then this graph still looks the same, still does this. It's just kind of shifted a little bit. So that outside part will move our asymptote up or down. If it's plus, it moves it up. If it's minus, it moves it down. Letter B.
Does that also move? Never mind.
So the shift that took place, the left shift, technically it is moving the asymptote, but the asymptote's a negative line, or an infinite line in both directions, so you can't really see it move.
But you also go down 1 with the. Okay.
All right, B. F at negative x plus 1. Okay, so that makes all x values, changes all x values. So if they're positive, they become negative. If they're negative, they become positive. Okay, it also flips over y-axis. Okay, so think about it. If I knew what this point was here, this point is now over here. That's why it's going to flip. Okay, this point we're staying consistent right now. We're also moving up 1. So now I'm going to go, because that plus 1, this comes up here. Okay, my asymptote moves, and it's going to do this. Changed opposite. If my x value sign changed, it's going to flip over the y-axis. So it actually changed it from decay to growth. Why is it growth? Because as it goes to the right in the red direction, or with the red graph, we go away from the asymptote. Letter C. Letter C. This. So that's going to do a couple things. It's going to move our point down here. So it moves my asymptote down. Oh, wait. Wait for C. Hang on. Look over there. See what's on the board over there? I'm sorry. I moved up. All right. This will flip over. So all y values change. Okay, so if they're positive, they change to negative. So with that note, and then it's going to go left 1. So this is now going to be down here. I'll make it an open dot, because then it also moves left 1.
Why does it go left 1? Oh, no, I guess it's
All right. Other things that took place, it flipped over. So even though it flipped over, my asymptote's not going to change. So we're just going to come up from the bottom. So this is what this one looks like. Okay. Where are we at? And I'll do the third one, and that'll be my last one, and then we'll collect them, okay? Okay, move on. Number 3. Kind of looks like a V, right? All right, so it looks like a V. So the main point that we're kind of worried about is this point right here is a good point for us to focus on what the graph is doing. So the first one, f at x plus 4 plus 3. So left 4, up 3. Agree?
Wait.
Because
I
outside.
messed up. Yeah, I'm confused.
All right, so left 4, so 1, 2, 3, 4, up 3. And it still looks like a check mark. We got an earthquake taking place. This thing's all vibrating. Okay, letter B. We have okay, so this changes all x values, and we also go up 5. Okay? So this x value is positive 1, so it's going to come here. So I'm going to put an open dot. That's the shift that took place because of the negative x. And then it moves up 5. So that's what that one did. And last one, we have negative f at x minus 2 plus 1. This changes all y values.
Now it goes right to down, up.
Yep, so, and then right 2 and up 1. So let's change our y value. So does the y value here change at all? No, it's a 0, so a negative 0 is the same thing. And then it's going to go, and then it opens opposite as well. Okay, so it's going to open down. So let's see. That point, left 2, up 1, open down. Looks like that. Cool. Would you do me a favor? Will you pass those all in, please? Who got in trouble? Did I?
No.
Brady forgot to staple.
You know, things like that happen.
Did I staple for him? Yeah, I'm gonna staple for him. Just chances. Oh.
Oh, you're beautiful. You're your favorite student for a reason. Just don't tell Zach. He'll get all jealous. He's giving you mad dog eyes. What's up, pal?
Chance. What? You pass up your homework?
Yeah, I gave it to him.
Cool, cool.
Thanks for checking. You know this class too well.
I do.
Here, you teach it now.
That put in the period 3 folder.
Yeah.
So official.
My password to my grade book, so you put the grades in, is dot, 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 dot. Jackson, you okay on that?
Oh, yeah.
Good. Hey, did you find any food out there?
No, I had hot Cheetos. I need water.
Woo, baby. All right. So, the what? And a burger?
Either or.
Dude, I want both. No, I don't want to drop 10. Alright. Here we go. Let's go back to our adventures of factoring. You ready? So my magic number on this one is going to be negative 60. Agree? In order to get a negative, I know I have positive negative. And the factors 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. 6 and 10, if I could get out of my madness. All right, we good so far? So of those, one being positive, one being negative, which would add up to negative 7? 5 and 12. Which one's negative? 12, thank you. Okay, so just kind of review on this real quick. X squared plus 5x minus 12x minus 60. X plus 5. Factor out a negative 12. X plus 5. Alright, so I get x minus 12 and x plus 5 for my factored version. Remember that? We so totally did factoring. Okay, second problem, you should be thinking, hey, maybe it's difference of 2 squares, but I have a greatest common factor first of 2. So I get 4x squared minus 9. Still with me? This is the difference of 2 squares. Remember the 2 comes down for the ride. Difference of 2 squares, how do I know? Because I know that 4x squared is the same thing as 2x times 2x. So I multiply the same thing together. 9 is the same thing as 3 and 3, separated by a subtraction. So 2x plus 3, 2x minus 3. Do not forget the original 2 out front, that greatest common factor. All right, then this one, holy cow. 9, 27, and 20 have nothing in common. Oh, no. Okay, we're talking about positive 180. Both sides have to be positive. So 1 and 180, 2 and 90, 3 and 60, 4 and 45. 5 and 30, 6, 7, 8. Does 8 work? No, 9. 9 works. 9 and 20. 10 and 18. 11 doesn't work. 12 and 15. I think we're done. Which of those factors work to give us positive 27? Oh, it's 12 and 15. Yeah, whoever said that. Sorry. So I get 9x squared, they're both positive, plus 12x, plus 15x, plus 20.
Yes.
Factor out a 3x, and that leaves me 3x plus 4. Factor out a 5, that leaves me 3x plus 4. So then my overall answer is 3x plus 5 and 3x plus 4. Yay! We totally did factoring together. Happy day. I'm sure it all came back to you instantly going, maybe some of it did. All right, may I move on?
Yes, you may.
Oh, thank you. I did water? What?
Hey, I thought there was.
All right, comparing models. Moving on. We're going to do linear. We're going to do exponential. We're going to do quadratic. We might not get to quadratic because, we've only done it for the past 4 weeks. So a linear equation, straight lines always have the same slopes. No matter what 2 points you pick, up and down the line, they're straight. They can go up, down, right, left, diagonal. Okay? So line, it's straight. The slope's the same. Slope is a constant. Okay, so if your slope between 2 points that's constant. If you find the slope between point this and point that, and then you pick 2 other points anywhere on it, the slope's always going to be the exact same. The y-intercept is always 0, b, so whatever the b value is, means you plug 0 in for x, and then the x-intercept means you're plugging in 0 for y and solving for x. Cool. May I move forward?
Yes.
Are we happy? So linear, dude, we're like so back August. All right, moving on. All right, so graph the function. So it looks like my y-intercept is negative 4. 1, 2, 3, 4. My slope is negative 2, so down 2, right 1. So we get that. Yay! Good catch. Graph the function. How do you know it's a line? Because the x value is just x. It's not in a denominator. It's not under a square root sign. It's not raised to an exponent. So, what is the y-intercept? Well, we just said the y-intercept is 0, -4. Remember, the y-intercept's a point, so you want to list it as a point. What is the x-intercept? That means I have to plug 0 in for y. Uh-oh. So if I do that, I'm plugging it in right there. So I get 0 equals -2x minus 4. Add 4. Divide by -2. So there's my x-intercept right there. Hey, what's the slope of this original function? Some of you aren't paying attention. What's the slope of my original function? -2. So the slope here is also -2. The slope here is also -2. What do you notice about the slopes? They're the same. They should be the same. Do I have to go through and plug those in and find the slope between 2 points?
No.
I hope not.
No.
But in case you are curious, it is this equation is used every time. And you identify for yourself 2 points that you like. You make one x1, y1. You make the other one x2, y2. Plug them in. Life okay so far?
Okay.
Happy day. Move on forward. Oh, look at this table. So it goes -2, -1, 0, 1, 4. Oh, so we kind of have a jump of 3 right there, but that's okay. These all go consistent, and then we have another jump of 3. But this is a linear equation. So, if I had a table of values to plug in, I think I would plug 0, 6 as the first thing. 0, 6 is guaranteed to be your y-intercept. And then I'd probably pick the 1, 7. Why is that? Because the values are small. So the first thing you would do is use your slope equation. Equals, let's see, I'm going to go 6 minus 7 and 0 minus 1. So I get -1 over -1, which is +1. So I have a slope of that. I believe I found my y-intercept already, which is what? 0,6, so my b value has to be 6. So if I use y equals mx plus b, I just found m to be 1. I know b to be 6. There's my linear equation. Oh, that's where this one went. Easter eggs and stuff. Great day. Everyone seem to make sense so far? Happy? Moving on. Exponential models. This means my variable, Jack, is a letter. It's an exponent. Got it?
Yes.
All right. So, growth. Growth looks like either this, if I had my thing, or growth could look like this. Because it is going away from our asymptote, it's growth. Decay, if we graph decay is going to look like this. Or it's going to look like this. So if you come to your asymptote as you go to the right, you have decay. The y-intercept, I'm going to plug 0 in for my x. Okay? So if you plug 0 in, if you had b to the 0 power, that is equal to? Thank you for saying 1. I had kids last period. 0, 0, 0, 0. I'm just saying like, 0. Maybe you didn't hear me. 0. I was like, oh my gosh. 0. No. If you raise a number or a letter to 0 power, your answer is always 1. The x-intercept is going to be blank, comma, 0, where I plug 0 in for the y, and then I have to go and solve it. The horizontal asymptote is, if I had this as my equation, a times b raised to the x plus c, my horizontal asymptote will be y equals c. If c is a negative number, remember, y equals a number is a horizontal line. Okay? If that was a minus c, then there'd be a minus c down here. Are we good? Almost done. Promise. Next one. Graph the exponential function. All right. Let's graph it. Let's find ourselves 2 points. So I'm going to plug 0 in first. 2 to the 0 power is? 1. 1. Good. 1 times half is half. Good, good, good. You guys are so smart.
Smash.
Smart. All right. Then I'm going to plug 1 in. 2 to the first. 2 to the first. 2. Half of 2. 1. I get 1 comma 1. All right. I have a plus 0 right here. So what's my asymptote? So y equals 0. So y equals 0 is this asymptote. All right, and then this is what my graph looks like. Does that appear to be growth or decay? Growth, because it's going away from the the asymptote. All right, now I'm not too worried about this. So if I were to find a point here and a point here, and then I were to find this point here and this point here, do we have different slopes between those? Yeah. So do we notice different slopes? Slopes are not equal to each other. Is this growth or decay? We already said it was growth because as you go to the right or as you go to infinity in the x direction, the y direction goes away from the asymptote. All right. What was this one? All right, parabola. We've done this. Does anyone need me to go back through the parabola stuff that we've only seen for the past 4 weeks?
Yes, please.
Oh, thanks, man.
Here we go.
So, few things. Negative b over 2a. Plug in. Axis symmetry is x equals negative b over 2a. Y-intercept is at 0, comma c, or plug 0 for x. And your x-intercepts are your roots. I don't think there's anything else I need to talk about. Can we graph this? Of course we can. We are pros at it. Hey, did you guys want a lot of homework tonight or a little? A lot? Okay, good. We'll do a lot. Okay, we got a whole lot. All right. All right. So I know you guys are probably gonna cry yourselves to sleep tonight, but
Let's sleep.
we have page 113. Now, if you want to do page 114, you get extra credit if you can find the problems. If you can find the problem.
Wait.
Blank.
It's blank. I'm gonna make a problem and do it.
Oh, don't you make promises you can't keep.
I will do it. I will make a problem and do it.
All right.
What plus what?
Jackson, did you get done with that?
To a poem.
Trying to walk out of here.
Wait, how do we do this?